Example number 3. For the function graph in figure 7-2h, letter A, identify the kind of function it could be. Letter B, on what interval or intervals is the function increasing or decreasing? And is the graph concave upward or downward? Letter C, describe something in the real world that a function with a shape of graph could model. Letter D, find the particular equation for the function you identify in part A, given that points 44.48 and 151.2 are on the graph. And letter E, confirm that your equation gives the graph in figure 7-2h. Okay. Our figure 7-2h, we start for answering letter A. So, number 1, identify the kind of function it could be. Now, looking at the graph itself, there are 2 distinctions that could be placed in here. Number 1, it could be an exponential function because of the trend. The trend of the graph is increasing upwards with concavity. So it tends to show us that it's half concave upwards. And at the same time, it could be a power function because, as you can see, the graph seems to contain our origin, but our exponential function states clearly that it could not contain the origin because it will try to approach your x-axis but will not reach any values in the x-axis. So we are going to choose the power function. So this is actually a power function. This is a power function, and we chose our power function because it seemed to contain the origin, as simple as that. Okay, number 2, or letter B, on what interval or intervals is the function increasing or decreasing, and is the graph concave upward or downward? Now we could notice that this graph, that this is increasing over its domain, and from the part shown, the graph shown, it is increasing from 0 going to x infinity. So it is concave down, still concave down. I'm sorry, it's concave up. Okay, please forgive me for that. It's concave upwards. And also at the same time it's increasing. So it's also increasing, as you could notice that this is going like that. It increases and it's positive, and at the same time the concavity is upwards. Okay, number 3, letter C. Describe something in the real world that a function with this shape of graph could model. Well, we could take any growth which rises exponentially as an example. For instance, the population growth in India or in Asia or the world generally. We could say that it's a kind of exponential growth from year 0 to year is equal to x, so an unknown year. And population growth, of course, from the word growth itself, so it tends to increase exponentially over time. So world population could be taken in here. World population. Letter D, or number 4, find a particular equation for the function you identified in part A, given that points 44.8 and 6152 or 151.2 are on the graph. So let's do that on the next slides. And since we decided that it is actually a power function, we would take the general equation for a power function, which is equal to y is equal to a x raised to b. And we have 2 points, therefore we are going to get 2 equations with 2 unknowns. So our set of points are A, we have 4 and 44.8. B, we have 6 and 151.2. 6 and 151.2. Okay, now we are going to have the equations. So our x is 4, then our y is 44.8. So we have 44.8 is equal to a times 4 raised to b. And on the second part, we have x is equal to 6 and y is equal to 151.2. And we have a and x is 6 raised to b. So how do we solve this type of set of equations with 2 unknowns? We could solve them using the algebraic method. And what are we going to do then? We are going to get the proportion or the ratio between the 2 unknowns. So we will have 44.8 over 151.2 is equal to, we could cancel our a now, so that leaves us with 4 raised to b and 6 raised to b. 44.8 over 151.2 is equal to, we could unite 4 and 6, so make it as a fractional quotient, a rational quotient, raised to b. Okay? And 4 over 6 is just equal to, what is 4 over 6? That's equal to 2 over 3. So 2 over 3 b, and this is 44 over 44.8 divided by 151.2. We would have to make use of our calculator. So 44.8 divided by 151.2, and that gives us 0.296296. 0.296296. Okay. We could shorten it actually. We could round off our decimal value here. So we are going to get 0.2963. That's equal to 2/3 b. And then what do we use in this kind of situation? We are to use the log function, right? So log of, okay, I think that's not the right place. We have to set a place here. So log of 0.2963 is just equal to, put your b down, and log of, right, log of 2/3 here. So log of 2/3. And in your calculator, we could solve the value of b by just pressing on your log functions. So our b now is log 0.2963 6/3 divided by log of 2/3. And this will give a value of b which is equal to, so our b is approximately 3. It's approximately 3.0. Now we could have our equation. So we will have our equation as, let us put it here. Okay. I need a colored one. So let us do it like this. What is our equation? Our equation is y is equal to, we have our b, oh, we're missing our a. Okay, how do we get our a? Just substitute b to, so let's do it here. And let's do it on this side. Okay, so to get our a, we just substitute our b to any of the given equations. It could be 1 or it could be 2. So for purposes of convenience, we will use 1. So for 1, then 44.8 is equal to a, 4 raised to 3, and that would give us a is equal to 44.8 divided by 64. So our a is approximately, let's make use of our calculator. Okay, that's 44.8. 44.8 divided by 64. That gives us 0.7. Okay, so now we are done with getting our a and b. So our a is 0.7 and our b is 3.0. So we will have 0.7 and x, and let's just take out the parentheses. Okay, so x raised to 3. So it's a power function, it's a cubic function, and it's 0.7 x cubed. So this is our equation. And letter E, confirm that your equation gives the graph in figure 7-2a. Okay, so you can see in the figure that it is concave upwards. And being concave upwards in power functions means that your a has to be, what is your a? It has to be positive. If it's positive, it will tend to have, what do you call this, an increasing trend. So similar to the exponential function. And also take note that our b is equal to 3. And our b equal to 3 is actually greater than 1. And if it's greater than 1, we have a concave upward graph. Am I correct? And if you substitute y is equal to 0, then x is equal to 0. And it contains the origin at its best. Okay, so you could use a grapher also to confirm that what our equation gives the graph of the function. The graph that you can see here is the graph of our function, 0.7x cubed. And that solves our problem for example number 3. So let's take a look at the other function and try to solve. This is another function, and you would most likely have one function in mind, because we have a remaining function, and out of all the functions we have 4 basic functions. We have linear function, parabolic functions or the quadratic functions, and power functions, and the exponential function. So let's see if the third or if the fourth graph, if the graph that we are going to work on will be the exponential function.